So hello everyone, welcome to the new YouTube section. Okay, on gate mechanical engineering. So 1 minute, let me take a pen. Okay, so on gate mechanical engineering, I welcome you all for the next YouTube session. Okay, so in this, so those people who have attended the last YouTube session, those guys will know that we had a detailed discussion on the LMTD, that is our logarithmic mean temperature difference, and also we studied the different types of heat exchangers. So here in the LMTD we studied the parallel flow as well as the counterflow heat exchangers, and we derived the whole derivation, which was the logarithmic mean temperature difference. Okay, so this was done in the previous class. So in today's class we'll be moving forward. We will learn what is AMTD. Okay, we learn what is AMTD, that is arithmetic mean temperature difference, and we will also learn the effectiveness of a heat exchanger and the derivation for the effectiveness of the heat exchanger. Okay, so let's move on to the slides. So the learning outcomes of today's lesson will be, so I will teach you guys what is a cross flow and multi-pass heat exchanger. So this is another type of heat exchangers. So we will see what is a cross flow and multi-pass type of heat exchangers. We will learn what is arithmetic mean temperature difference, that is AMTD formula. Okay, arithmetic mean temperature difference, the AMTD formula, we'll be learning it. We will also see what is an effectiveness of heat exchanger, and we will solve the derivation for the effectiveness of a heat exchanger, and then we will move on to solve two other derivations, namely the effectiveness of a parallel flow heat exchanger and the effectiveness of a counterflow heat exchanger. Along with this, if time permits, I will be solving 5 problems with regard to heat exchangers. Right, so let us move on to the class. Okay, so detailed discussion on heat exchangers part 2. So in the previous class we had a detailed discussion on the types of heat exchangers and also the LMTD method. So today we'll be moving on to the AMTD method, and we will also see what is an effectiveness of the heat exchanger. Right, let us move on to the class now. So we'll move on to cross flow or multi-pass heat exchangers. So what is basically a cross flow or a multi-pass heat exchanger? Okay, when the flow conditions are much more complicated. Okay, when the flow conditions are much more complicated in any heat exchanger, we will be using a type of heat exchanger called as the cross flow or multi-pass heat exchanger. मैं एक और बार बताऊंगा, जब भी फ्लो कंडीशंस बहुत ज़्यादा कॉम्प्लिकेटेड होता है, आपको पता है कि एक हॉट फ्लूइड होता है, एक कोल्ड फ्लूइड होता है एक हीट एक्सचेंजर में। तो हॉट फ्लूइड अगर गैस हो गया और कोल्ड फ्लूइड भी गैस हुआ और बाई चांस वो एक इनर गैस हो गया, वरना हॉट फ्लूइड एक लिक्विड होता है, कोल्ड फ्लूइड भी लिक्विड हुआ पर वो किसी और तरीके के लिक्विड हो गया, तो क्या होता है, फ्लो कंडीशंस बहुत ज़्यादा कॉम्प्लिकेटेड हो जाते हैं। ओके, द पाइप्स में गेट एलोंगेटेड, द पाइप्स में बर्स्ट बिकॉज ऑफ द टेम्परेचर ऑफ द लिक्विड। ठीक है, ऐसा सब कॉम्प्लिकेटेड कंडीशंस हो जाते हैं फ्लो कंडीशंस में से। तब ऐसे फ्लो कंडीशंस कॉम्प्लिकेटेड होंगे तो हमें पता है कि किस तरीके से फ्लूइड यूज करने से कैसा कैसा कंडीशंस आ सकता है। तो जब भी दो कॉम्प्लिकेटेड फ्लूइड्स को हम यूज कर रहे हैं, हमें पता रहेगा कि उसका फ्लो कंडीशंस कॉम्प्लिकेटेड रहेगा, तब हम एक टाइप ऑफ हीट एक्सचेंजर को यूज करेंगे जिसको हम क्रॉस फ्लो या मल्टीपास हीट एक्सचेंजर्स कहकर पुकारते हैं। तो इस क्रॉस फ्लो और मल्टीपास हीट एक्सचेंजर्स में हमारा ये कॉम्प्लिकेटेड फैक्टर कैसे कम हो जाता है? This complicated flow conditions which are present in a cross flow and heat multipass heat exchangers, how do they get lessened? Okay, so here we use something called as a correction factor. Okay, we use the application of a correction factor. हम correction factor नाम का एक चीज लेंगे जिसकी वजह से ये जो flow conditions complicated हो गए हैं वो easy हो जाता है। The flow conditions which actually got complicated, okay, they will get easy by the application of a correction factor, and such heat exchangers which use these correction factors are called as cross flow and multipass heat exchangers. So a correction factor क्या है? This F which is present over here, it is the correction factor. ये F का जो अल्फाबेट है इधर, F का जो टर्म है उसको हम करेक्शन फैक्टर कहकर पुकारते हैं। तो ये F का वैल्यू हमें कैसा मिलता है? Okay, basically a graph will be there. So this will be the graph where F values are written on the x-axis. There will be P values written on the y-axis, and there will be R values which will be present in the graph. So basically in the gate exams, those guys will give you either P, okay, they will give you P values or the R values, and you have to find out the F value, or else they will give the F value or R value, you have to find out the P value, then substitute to this equation and find out the heat exchanger rate. ठीक है, तो F का वैल्यू देंगे, R का वैल्यू देंगे तो आप P का वैल्यू निकाल सकते हैं, P का वैल्यू देंगे, R का वैल्यू देंगे तो F का वैल्यू निकाल सकते हैं, F का वैल्यू P का वैल्यू देंगे तो R का वैल्यू भी निकाल सकते हैं, है ना. So that is how they'll do it. Okay, so basically they will provide you two of the values. The third value you have to formulate it. So basically they will give you a graph, or else they will name these terms T1 T2 or T2 T1, so that you can find any one of these terms. P will be given, F will be given, and using the formula you can find out the R value. If they provide you the graph, you can find out the R value through the graph. And after finding out this P R values, you can easily find out the F value, पी आर वैल्यू या कुछ भी वैल्यू, तीनों में से दो वैल्यू देंगे, तो दो वैल्यू को लेकर आप एक वैल्यू का आंसर निकाल सकते हो और उसको इस इक्वेशन में डालना है, विच इज यूए इंटू एलएमटीडी इंटू एफ. यूए क्या है, ओवरऑल हीट ट्रांसफर कोएफिशिएंट, एरिया, एलएमटीडी लॉगरिथमिक मीन टेम्परेचर डिफरेंस, जो डेरिवेशन से हम सॉल्व करते हैं, बाद में एफ करेक्शन फैक्टर. इन सबको डालने से हमें क्यू का वैल्यू मिल जाता है. ठीक है, क्यू का वैल्यू विच इज नथिंग बट अवर रेट ऑफ द हीट एक्सचेंजर. Okay, let's move on to the next one. Okay, so this is how a cross flow or multi-pass flow heat exchangers look like. Okay, they will consist of numerous number of tubes. They house, one minute, okay, they house मतलब उनके अंदर बहुत सारे ट्यूब्स रहते हैं. ठीक है, उनके अंदर बहुत सारे ट्यूब्स रहते हैं और ये होता है क्रॉस फ्लो. व्हाट डज क्रॉस फ्लो मीन? द फ्लो हैपनिंग इन ए क्रॉस वे. So this is what we cross, right? So this is a cross. What do we tell? The person crossed me, मतलब वो मेरे सामने से चला गया. So that is called as a cross flow. ठीक है, so this is a cross flow and this is the tube flow. The fluids coming out of the tubes are called as tube flows, and the fluids going in a cross way are called as cross flow heat exchangers. So this is how the flows happen in a cross flow or multi-pass heat exchangers. Multi-pass का मतलब क्या है? They consist of numerous number of tubes. अगर बहुत ज्यादा ट्यूब्स है, if there are more tubes present in a heat exchanger, then it is called as multi-pass. What is multi-pass? Basically double pipe heat exchanger जो हमने last class में देखा था, the double pipe heat exchanger, it had only two pipes, right? That means it had only two tubes. Here multiple number of tubes are there. So the fluids they can pass in various ways. Fluids जो है वो heat exchanger के अंदर रहते हैं, they can flow in numerous number of ways. ठीक है, वो बहुत ज्यादा ट्यूब्स में पास कर सकते हैं. So ये होता है बहुत ज्यादा ट्यूब्स. That is what we call as multi-pass. That is, they can pass through any number of tubes. So such heat exchangers are called as multi-pass or cross-flow heat exchangers. So you can see the diagrammatic representation of a cross-flow heat exchanger. Here what happens, there will be an inlet present here. So you can see the arrow mark is telling it is going inside. Okay, arrow mark क्या दिखा रहा है? It is going inside the membrane, है ना? और ये it is telling it is going outside the membrane. And here it is telling it is going inside the heat exchanger. Here it is showing it is going outside the heat exchanger. So how does this thing happen here? It happens in a 90-degree manner, right? 90-degree manner में हो रहा है, ये भी आप देखो. तो 90-degree manner में हो रहा है. That is the reason they are cross flow and multi-pass. Cross flow because of this flow, perpendicular flow, and multi-pass because they have a numerous number of tubes. Okay, they have a numerous of tubes present in them, and you can see how the flow happens. It happens in a cross manner. एक के ऊपर जाता रहता है flow. Okay, now let's see the sub. Okay, so you can see these are different types of multi-pass or cross flow heat exchangers. So this is one separator cross flow heat exchanger. This is three separators. This is again n number of separators can be allocated to the multi-pass or cross flow heat exchangers. If this is n equals 1, this is n equals 3. So this is again 1, 2, 3, 4, 5. So n equals 5 and n equals 7. So these are the number of separators which are present inside the membrane of the heat exchanger or inside the heat exchanger. So what are separators? So we heard a name called as baffles, right? We heard this name in the previous class, that is we cross flow heat exchangers or shell and tube type heat exchangers, right? Shell and tube type heat exchangers or cross flow and multipass heat exchangers, they use something called as baffles. And what are baffles? They are flow directing or obstructing pipes or veins. Okay, I'll write it here. Flow directing or obstructing. Okay, flow directing or obstructing veins or pipes are called as baffles. And what do baffles do? They help in the direction of the fluid or flow of the fluid and maximize the efficiency of the heat exchangers. So what are basically baffles? Baffles are nothing but separators. Okay, they are used to direct the flow of the fluid, मतलब जो भी fluid अंदर जा रहा है और अंदर एंटर कर रहा है वो उस फ्लो का डायरेक्ट करते हैं और उस फ्लो को शायद ऑब्स्ट्रक्ट भी करते हैं. इफ दे आर ऑब्स्ट्रक्टिंग देन दे आर कॉल्ड सेपरेटर्स, इफ दे आर फ्लो डायरेक्टिंग देन दे आर कॉल्ड एज baffles. So what are basically baffles? Baffles are the flow directing or obstructing veins which are present inside a heat exchanger, and they help in directing the flow of the fluid, which increases the efficiency, that is maximizes the efficiency, right? So जो भी efficiency को maximize करता है, जो भी fluid का flow direct करता है या obstruct करता है, उस चीज को हम separator या baffle कहकर पुकारते हैं. So you can see here another multiple set of diagrammatic representations I have given you guys here. So you can see the obstruction of flow happens here, right? तो क्रॉस फ्लो में बेसिकली क्या होता है? देयर विल बी टू टाइप्स ऑफ फ्लूइड्स. ओके, 90 डिग्री में फ्लो होता है, राइट? इट द फ्लो हैपेंस इन 90 डिग्री. ओके, the flow happens in 90 degree basically, so you don't have to mix the fluids. Okay, if the fluids happen in the same manner, so there will be mixing of hot and cold fluids. If the mixing of hot and cold fluid happens, you cannot experience a heat exchange or you cannot experience a temperature difference. So there will be providing, okay, the heat exchangers will have something called as separators or baffles, okay, which direct the flow of the fluid or obstruct the flow of the fluid from entering or physically mixing with each other, right? So you can see here another graph here. So basically in the first slide, okay, which is the P and R slide, I showed you guys one formula, Ti T2 Ti T2. So you can see here, this is the small ti, this is the small t2, this is the large ti, this is the large t2. Okay, capital Ti, capital T2. Now we shall go to the previous example over here. Okay, not this one. Okay, here. Okay, so here क्या हो रहा था? This was happening. I can show you this in this slide only. Okay, तो इधर क्या हो रहा है? The cross flow is happening. So what is this? T2. This is T1. This is T1, capital T1, this is capital T2. So you guys understood? So the fluids which enter from the up, that is top of the heat exchanger membrane, जो भी ऊपर से fluid आता है, that will be capital T1, और जो नीचे से fluid चला जाता है, that will be capital T2. जो बाजू में आता है, बाजू से चले जाता है fluid, that will be T1, और जो बाजू से enter करता है वो fluid हमारा small t2 बन जाएगा. So by using this formulas also, you guys can find out the values of P and R. Okay, F value they will mostly give you, or else they will give you a graph. If they provide you F and P values from this capital T1, capital T2, small t1, small t2, you guys can find out the value of P and R. Okay, so you can see here, this is how the graph is. F, P, R will be the graph. P is T2 minus T1, that is small t2 minus T1 divided by large T1 minus T1. Okay, and P1 also I have given you guys the formula here. So you can see here the formula for P1 is written here. P1 is small t2 minus small t1 divided by capital T1 minus small t1, and the formula for R is capital T1 minus capital T2 divided by small t2 minus small t1. So this was at the AMTD. Okay, this was the arithmetic mean temperature difference. Okay, so basically what we saw now is for the cross flow and multipass heat exchangers. Okay, the use of correction factor. Okay, the use of correction factor in a cross flow and multipass heat exchangers, we saw it now. Now we will move on to the next part, which is the arithmetic mean temperature difference. So what we saw in the previous slides, they were nothing but the arithmetic mean temperature difference when a correction factor has to be utilized, okay, in a cross flow and multipass heat exchangers, right? in a cross flow and multipass heat exchangers जो भी हम करेक्शन फैक्टर को यूज करते हैं वो हमने पिछले स्लाइड में देखा था. अभी इस स्लाइड में हम अरिथमेटिक मीन टेम्परेचर डिफरेंस क्या है देखेंगे. सो बेसिकली अरिथमेटिक मीन टेम्परेचर डिफरेंस इज व्हेन द टेम्परेचर वेरिएशंस आर रिलेटिवली स्मॉल. When the temperature variations are relatively small, then we use something called as AMTD, that is arithmetic mean temperature difference. Temperature variations are relatively small, मतलब hot fluid का वैल्यू 25 आएगा, cold fluid का वैल्यू भी 25 आएगा, दोनों का वैल्यू 25 है. इसको हम LMTD में सब्स्टिट्यूट करेंगे तो आंसर क्या आएगा. LMTD will provide an answer of 0. Okay, so in such cases, when the hot fluid temperature difference or temperature variance or the cold fluid temperature difference or the temperature variators or variations, when they are relatively small, okay, we use something called as arithmetic mean temperature difference to get a fairly accurate results. Okay, to get fairly accurate results, we use something called as arithmetic mean temperature difference. So what is the AMTD formula? It is theta max plus theta minimum divided by 2. That is basically, if 25 and 25 are there, if you substitute this in the equation of LMTD, you will get the answer as 0. But the same 25 plus 25 by 2, you will get the answer as 25. Okay, so when such variations are obtained, okay, we will get approximately straight lines. Matlab, we can assume that no heat exchanger happens there, but even if the temperature variations are relatively small, there is a temperature difference, right? And because of which there will be heat exchange happening. So we use something called as arithmetic mean temperature difference in such cases, which is AMTD theta max plus theta minimum by 2. Okay, now we'll move on to the effectiveness of heat exchanger. Okay, what is effectiveness of heat exchanger? Effectiveness of heat exchanger is defined as the formula, or it is defined as the ratio of the actual rate of heat transfer to the maximum possible rate of heat transfer. Okay, so I'll write it here. It is actual rate divided by maximum possible rate. Okay, what is effectiveness? It is actual rate of heat transfer divided by maximum possible rate of heat transfer. मतलब जो एक्चुअल रेट ऑफ हीट ट्रांसफर है, ठीक है, जो रेट ऑफ हीट ट्रांसफर हमें कैलकुलेट करने से मिलता है वो आंसर, और जो मैक्सिमम हीट ट्रांसफर हो सकता है हीट एक्सचेंजर के अंदर, उसको हम इफेक्टिवनेस कहकर पुकारते हैं. वी कॉल इट एज द इफेक्टिवनेस ऑफ द हीट एक्सचेंजर. मतलब द मैक्सिमम पॉसिबल रेट, मतलब एक हीट एक्सचेंजर में मैक्सिमम हीट एक्सचेंज रेट और हीट ट्रांसफर रेट हो सकता है 1 किलोवाट, पर उस हीट एक्सचेंजर का एक्चुअल रेट मतलब अभी जो कैलकुलेट किया है वो रेट है 0.5 किलोवाट, तो उसका हीट एक्सचेंजर का इफेक्टिवनेस क्या हो जाएगा? एक्चुअल रेट कितना है? 0.5, मैक्सिमम रेट है 0.1, so 0.5 divided by 0.1, the answer what we will get will be the effectiveness of a heat exchanger. Okay, so that will be basically the effectiveness of a heat exchanger. It is defined as the ratio of the actual rate of heat transfer to the maximum possible rate of heat transfer. So how do we find out this effectiveness? How can we find out the derivation of effectiveness? Okay, the derivation of effectiveness is given by the formula. We know that by steady state of heat transfer, we know that by steady state of heat transfer, heat lost by hot fluid is equal to heat gained by cold fluid. ये हमने LMTD के derivation में भी देखा था, है ना? Heat lost by hot fluid is equal to heat gained by cold fluid. This is according to the steady state heat transfer, right? So now first one will be exit temperature of hot fluid is equal to inlet temperature of cold fluid. तो इधर क्या है? exit temperature heat lost, inlet temperature heat gained. Then again exit temperature of cold fluid, again heat lost, inlet temperature of hot fluid heat gained. So basically if you take this steady state heat transfer into consideration, ठीक है, ये अभी steady state heat transfer को हम consider करेंगे, which is heat lost by hot fluid is equal to heat gained by the cold fluid. तो हमें दो केसेस मिलेंगे, है ना, क्योंकि हमें पता है कि हॉट फ्लूइड का इनलेट एग्जिट टेम्परेचर दो होता है, मतलब इनलेट टेम्परेचर होता है और आउटलेट टेम्परेचर होता है, और कोल्ड फ्लूइड का भी इनलेट टेम्परेचर होता है, एग्जिट टेम्परेचर होता है. तो अभी दोनों केसेस लिखेंगे. फर्स्ट केस क्या होगा? एग्जिट टेम्परेचर ऑफ हॉट फ्लूइड है जो है वो इक्वल करेगा इनलेट टेम्परेचर ऑफ कोल्ड फ्लूइड. द एग्जिट टेम्परेचर ऑफ हॉट फ्लूइड विल बी इक्वल टू द इनलेट टेम्परेचर ऑफ कोल्ड फ्लूइड. Second thing will be exit temperature of cold fluid will be equal to inlet temperature of hot fluid. Okay, first one जो आउटलेट टेम्परेचर है हॉट फ्लूइड का वो कोल्ड फ्लूइड का इनलेट टेम्परेचर से इक्वल करेगा. दूसरा वाला है कोल्ड फ्लूइड का जो आउटलेट टेम्परेचर है वो इनलेट टेम्परेचर से इक्वल करेगा. Okay, let's solve the derivation of effectiveness now. Okay, so effectiveness is given by the letter epsilon. So we know what is the definition of effectiveness. Effectiveness is defined as actual rate of heat transfer divided by a maximum possible rate of heat transfer. ठीक है, actual rate of heat transfer divided by maximum possible rate of heat transfer. So we can write Q max, that is the maximum possible rate happening is maximum possible rate of heat transfer में heat का capacity क्या होगा, heat का capacity क्या होगा, it will be C minimum, right? C maximum will be actual rate. C maximum will give us the actual rate. Okay, so this is basically C minimum will be the actual rate. So C minimum into THI minus TCI. So let's go to the previous page again. So heat lost by hot fluid is equal to heat gained by cold fluid. Exit temperature of hot fluid, so this is lost. Inlet temperature of cold fluid is gained, right? Exit temperature of cold fluid is lost, inlet is gained. तो इधर क्या मिला हमें, THI और TCI इन दोनों में gain हुआ है ना. THI and TCI are gained here. Inlet temperature of cold fluid, inlet temperature of hot fluid. This is nothing but gained. So that is what we'll take for the maximum possible rate of heat transfer. The minimum heat capacity into THI minus TCI. Right? Minimum heat capacity, maximum heat capacity or maximum possible rate of heat transfer is minimum heat capacity into THI minus TCI. So basically what is C? What is heat capacity? I explained this in the previous class, in the LMTD class. Okay, heat capacity is nothing but the mass into specific heat. What is basically heat capacity? Heat capacity is the total capacity of the material to produce a maximum heat with its mass. Heat capacity is the total capacity of the material to produce maximum heat along with its mass. Okay, M into Cp, that is mass into specific heat. Okay, mass into specific heat. So this will be my answer of Q max. Now my Q actual. Okay, the actual rate of heat transfer. Actual rate of heat transfer क्या होगा, अगर मैं CH मतलब heat capacity of hot fluid which is MH into CPH. What is CC? It is MC into CPC. MH into CPH and MC into CPC will give my heat transfer, that is heat transfer capacity for hot fluid and heat transfer capacity for cold fluid. Right? So Q actual for hot fluid will be hot fluid का temperature difference क्या है, inlet minus outlet. Okay, CH is the heat capacity, so CH heat capacity temperature difference which is THI minus TH naught. Coming to cold, it is CC TC naught minus TCI. क्योंकि heat exchanger में क्या होता है, heat exchanger में cold fluid का जो inlet temperature रहता है वो कम रहता है, cold fluid का जो outlet temperature रहता है वो ज्यादा रहता है. Right? Hot fluid का inlet temperature ज्यादा रहता है. Hot fluid will be around 100 degree centigrade and when it comes out of the heat exchanger it will be around 25 degree centigrade. Cold fluid inlet temperature will be around 25 degree centigrade but when it comes outside it will be around 75 degree centigrade. Right? Heat exchanger में यही होता है. Hot fluid का inlet temperature ज्यादा रहता है, cold fluid का outlet temperature ज्यादा रहता है. इसलिए ये TC naught minus TCI है क्योंकि we need to get a positive value here, है ना. So here also we'll get a positive value because THI is greater than TH naught and TC naught is greater than TCI. So TC naught minus TCI. So what is basically effectiveness? Effectiveness का formula क्या है? Actual rate by maximum possible rate. Okay, actual rate by maximum possible rate is the effectiveness का formula, है ना. Actual rate by maximum possible rate. So basically what is actual rate? C minimum by THI minus TCI. So this is maximum possible rate. Actual rate I have written here. So 1 minute, let me erase this. Okay, so that you guys can see the formulas. Okay, yes. तो मैक्सिमम पॉसिबल रेट क्या है, सी मिनिमम टी एच आई माइनस टी सी आई. एक्चुअल रेट क्या है, हॉट फ्लूइड के लिए ये आंसर आ जाएगा मेरा. ओके, हॉट फ्लूइड आई टेक दिस, एंड फॉर कोल्ड फ्लूइड आई गेट दिस आंसर. If CH is lesser than CC, then CH will become C minimum. So C minimum by C minimum दोनों cancel हो जाएगा. So this will be for my THI minus TH naught. This is for my hot fluid. And if CC is less than CH, CC will become C minimum. ठीक है, तो ये CCCH. ओके, if इसका वैल्यू ज्यादा है, ओके, इसका वैल्यू कम है, ठीक है, so that is what they are telling here. If CH is having maximum value, it will be called a maximum heat capacity, and if CH is having minimum value, it will be called a minimum heat capacity. तो अगर CH का वैल्यू CC से कम है तो CH क्या हो जाएगा, वो मिनिमम हीट कैपेसिटी हो जाएगा. मतलब C मिनिमम और CH का वैल्यू सेम रहेगा, तो C मिनिमम CH दोनों कैंसिल हो जाएगा. इफ दिस इज द पॉसिबिलिटी, सो दिस विल बी द आंसर और फॉर्मूला फॉर हॉट फ्लूइड. And if CC is less than CH, CC will become C minimum. C minimum cancels, and this will be the formula for heat capacity of the effectiveness of a cold fluid. Right? We'll move on to the next one. Okay. Now we will do the heat exchanger analysis by NTU method. Okay, we'll do the heat exchanger analysis by NTU method. So why are we doing this? If we know only the inlet temperatures, if we know only the inlet temperatures, that is THI and TCI, if we know only the inlet temperatures THI and TCI, we will be using something called as NTU method. What is NTU method? It is a number of transfer units. Okay, what is NTU method? NTU method is nothing but the number of transfer units, and NTU is given by the formula UA divided by C minimum. U is overall heat transfer coefficient, A is the area, C minimum is the minimum heat capacity rate or minimum heat capacity. Let's move on to the formula now. The expression for effectiveness of a parallel flow heat exchanger. So first we will see the expression for effectiveness of a parallel flow heat exchanger. So this one has half of the steps which are similar to the LMTD derivation. Half steps are similar to the LMTD derivation, and the rest we will formulate it in the class. Right? So this is the graph. Okay, this is the graph you guys can see here. So what is this basically? Parallel flow. Parallel flow का मतलब क्या है? The fluids move in same direction. Okay, if the fluids move in the same direction, then we call it as parallel flow heat exchanger. So hot fluid का direction भी same है, cold fluid का direction भी same है. You can see here shell and tube exchanger it is. Okay, so this is the diagram of a parallel flow heat exchanger. Let us move on to the derivation now. So you can see this is the graph. So parallel flow में क्या होता है? The fluids move in the same direction. मतलब hot fluid भी inlet से outlet से ही जाएगा, cold fluid भी inlet से outlet ही जाएगा. Hot fluid also will move from the inlet to outlet. Cold fluid also will move from the inlet to outlet. So you can see here THI, okay, THI, TCI, TH0, TC0. This is our area. Okay, differentiation of area is dA. And what is DTH? What is DTH? Tell me here. DTH is THI का value ज़्यादा है ना, so it will be THI minus TH0. Okay, DTC. DTC क्या होगा इधर? What will be DTC का value? DTC is TC0 minus TCI. Right? DTC is TC0 minus TCI, क्योंकि TCI का वैल्यू TC0 से कम रहेगा. We know that hot fluid का inlet ज़्यादा temperature रहेगा. This will be maximum. Here the outlet fluid will be maximum. So DTH and DTC is TH0 minus TCI and C0 minus CI. Now we know that what is Q? Q is equal to UA delta T. Right? What is Q? Q is basically UA delta T. So we will differentiate this. तो इनमें से Q and A are not constants, whereas U is a constant and delta T will be TH minus TC. What is delta T here? How many fluids are there here? There is one hot fluid and there is one cold fluid. तो ये क्या होगा? TH minus TC होगा. So dq is equal to UA delta T. I'll differentiate it. Q is not a constant, A is not a constant. So what is the formula I'll get? I will get the formula as dq is equal to UdA TH minus TC. This is my first formula, right? Let me erase this, guys, 1 minute. Okay. Now, cool. Now, the next one. Okay, this one मिल गया. This is my first equation. अभी next क्या है? मैं इस equation को hot fluid के बतौर और cold fluid के बतौर लेना चाहता हूँ. This dq equation again I take in the terms of hot fluid and cold fluid. So in the hot fluid, what is there? Hot fluid has a mass mH, it has a specific heat Cph, and it has a difference in temperature dTh. Right? Hot fluid has a mass flow rate mH. M of H is mass flow rate of hot fluid. It has Cp of H, that is the specific heat of a hot fluid, and dTh, that is the temperature difference of a hot fluid. So similar to hot fluid, even cold fluid will have. So what will cold fluid will have? Its mass flow rate mc, its specific heat Cpc, and its temperature rate dTc. Right? So मेरा dq इसमें क्या होगा? Okay, what will be my dq according to hot fluid? mH into Cph into dTh, the product of these three terms. And for cold fluid also, these three will be my mass fluid, that is mc into Cpc into dTc. Now see here properly. Okay, I will erase it once again. Okay, because there are too many things, so you guys will get confused in this derivation. So do not get confused, it is only about concepts. Okay, now see here, the inlet of hot fluid is moving from a higher region and reaching a lower region, whereas the inlet of a cold fluid is moving from a lower region to higher region. तो अभी 5 से 1 तक गिर गया, so what will this be? 5 minus 1, right? And इधर 1 से 5 तक चला गया, so what will this be? 1 plus 5, right? So this is 5 minus 1 and this is 1 plus 5. So it is at a higher region, it moves down, so it is subtracting itself. So it is going in a negative direction. Higher से lower जा रहा है, it is going in negative direction, whereas the cold fluid is moving from lower to higher, positive direction. So what will my dq be? My dq for hot fluid will carry a negative sign. Since it is moving from higher to lower, it is subtracting itself, whereas cold fluid is moving from lower to higher. So this will be positive, this will be negative. Now let me take this dq. Okay, this dq, this is for hot fluid. Okay, let me put a square, and this is for cold fluid. अभी मुझे dTh का वैल्यू चाहिए और dTc का वैल्यू चाहिए. Okay, I want the values of dTh and dTc. Okay, so basically what will dTh be? It will be minus is there, so minus dq mh cph. Okay, minus dq mh cph will be the value. Okay, dTh is not there. Okay, here also dTc is not there, it get cancelled. So minus dq mh cph. Similarly dTc will be dq mc cpc. Hot fluid has a negative one, so negative sign comes here. Cold fluid has no negative signs, it is positive, so this remains. So we formulated the values of dTh and dTc. Now what is mH into Cph? We saw this in the LMTD derivation also. mH into Cph, the mass flow rate and specific heat, it is nothing but Cc, the heat capacity rate. So Ch. Okay, so mH into Cph is Ch and mc into Cpc is Cc. So basically dTh minus dTc is minus dq 1 by ch plus cc. So what will this be? It will be dq by ch minus dq by cc will be there, and here minus will come. So minus dq is common, so minus dq बाहर जाएगा तो अंदर क्या रहेगा? 1 by ch plus 1 by cc, है ना? Minus common है, minus into minus plus remains here. So this will be my second equation. Okay, this is my second equation. And one more thing, डी टी एच माइनस डी टी सी, इसमें डी कॉमन है तो डी को बाहर निकाल दिया, सो दिस विल बी डी ऑफ टी एच माइनस टी सी, राइट? डी टी एच माइनस टी सी इज नथिंग बट डी ऑफ टी एच माइनस टी सी, so this will be my third equation. Okay, so we formulated our third equation also. Now let us move forward. Okay, dth minus dc equals minus d to th minus tc. Okay, तो इधर क्या लिखा है? What is there here? Minus dq 1 by ch plus cc is equal to dth minus dc. So let's substitute this. Substituting that, we'll get the fourth equation. We are just substituting th and tc's values. Okay, after that, what is dq? What is dq? Go back. The first one which we formulated, dq is nothing but uda into th minus tc, overall heat transfer coefficient into area into the temperature difference. So that I will write back again in this equation. Okay, dq का formula लिखूंगा मैं. अभी क्या है? Minus uda th minus tc, 1 by ch plus 1 by cc is there. This th minus tc which is present over here, I will move it to the right hand side. This th minus tc which is present over here, I will move it to the right hand side. It will go and settle in the denominator. This one will go and settle in the denominator. Here minus uda 1 by ch plus cc will be there. So now I will integrate this whole value. Okay, I will integrate this whole value. So here all are in differentiating thing. So all are not constants. Here no constant is present. तो पूरा में इंटीग्रेशन आ जाएगा. Either u is a constant, ch and cc is a constant, a is not a constant. So dA will become, so integration of dA. Integration of dA is nothing but a. Integration of dA is nothing but a. And here exit and inlet का we'll get exit and inlets integration. So let's go back again to our graph here. So graph में क्या लिखा है? इनलेट का क्या टेम्परेचर डिफरेंस है? THI माइनस TCI. और एग्जिट का क्या टेम्परेचर डिफरेंस है? TH नॉट माइनस TC नॉट. So substitute this in exit and substitute this in inlet. You'll get inlet or exit का temperature difference, which is ln of TH naught minus TC naught by THI minus TCI minus. So this will be my fifth equation. So till here we had substituted everything in our LMTD equation, right? LMTD equation में हमने ये सब solve किया था. अभी हम क्या करेंगे next? The ln which is present here, the logarithm which is present here, I will move it to the right hand side. The logarithm present here, I will move it to the right hand side. तो क्या होगा? The right hand side will become e power minus ua. Whenever you move, जब भी आप एक logarithm को या ln logarithm to the base 10 इस फंक्शन को राइट हैंड साइड या लेफ्ट हैंड साइड, व्हेन यू चेंज द साइड्स, जब आप साइड्स को चेंज करोगे, देन इट विल बिकम e पावर. Okay, when the ln is in the one side and when it moves on to the next side, it becomes e power, it becomes an exponential. So that is what we have got here, the sixth one. Now what is effectiveness formula? What are we trying to find out here? We are trying to find out effectiveness. So effectiveness का formula क्या है? Actual rate of heat transfer divided by maximum possible rate. Actual rate of heat transfer divided by maximum possible rate, right? A divided by MP. तो write it for hot fluids and cold fluid. तो hot fluid and cold fluid ये हमने अभी अभी solve किया था, तो ये लिखेंगे. Now we will try to find out, okay, CH का value. तो CH into THI minus TH naught. Okay, what is this value? This value will be equal to the multiplication of these both values, right? CH into THI minus TH naught is the multiplication of both these values. Okay, similarly CC into TC naught minus TCI is the multiplication of both these values. C minimum THI minus TCI into epsilon. So write it down. E into C min THI minus TCI is equal to CH THI minus TH naught. तो इधर से मैं TH naught का वैल्यू बाहर निकालूंगा. तो TH naught will be THI minus epsilon C minimum divided by CH THI minus TCI. My seventh equation. Similarly, ये जो equation है cold fluid का, I will write it in one term and I will find out the value of TC naught. Here TH naught was there here, so it is basically negative. तो इधर मुझे negative sign आएगा. Here TC naught is positive, so I'll get a positive sign here. TC naught will move this side, negative hoga. So what I'll get, the seventh equation will have a negative sign, whereas the eighth equation will have a positive sign. That is, hot fluid will have a negative sign and cold fluid will have a positive sign. So TH naught और TC naught का value मिल गया. So go back to the previous page. TH naught और TC naught दोनों है ना? तो उन दोनों का values मिल गया. Substitute it back to the equation. By substituting back to the equation, what we'll get? THI minus epsilon C minimum CH THI minus TCI minus TCI epsilon C minimum by CC THI minus TCI divided by THI minus TCI is equal to e power minus UA 1 by CH plus 1 by CC. And this one we got here. Now see here, which are the common terms here? You can see THI TCI and again TCI THI, right? THI minus TCI is present here, whereas THI minus TCI are also present in the brackets. So let's take the common out of it. Taking the common THI minus TCI out of this equation, we will get it as THI minus TCI, which is the common, which is equal to into, that is कॉमन बाहर निकाल दिया तो उधर क्या रहेगा, वन रहेगा, है ना, इट विल बी रिप्लेस्ड बाय वन. सो टेकिंग THI minus TCI common, we'll get in the brackets 1 minus epsilon C minimum into 1 by CH plus 1 by CC divided by THI minus TCI is equal to e power minus UA 1 by CH plus 1 by CC. Now cancel both these terms. Cancelling both these terms, I'll get 1 minus epsilon C minimum 1 by CH plus 1 by CC on one side and e power minus UA 1 by CH plus 1 by CC on the other side. Now what do I have to find out? I have to find out epsilon, right? So epsilon C minimum is in the negative here. It is in the negative. तो इसको positive करना है तो क्या करना है मुझे? What should I do to take the epsilon as positive? I have to shift the sides. That is, I have to move to this left hand side. So moving this to the left hand side, what I'll get it as 1 minus e power minus UA 1 by CH plus CC is equal to epsilon C minimum. Now I can find out epsilon easily. So what is epsilon? 1 minus e power minus UA divided by C minimum, the term which is present over here. So epsilon will be 1 minus e power minus UA 1 by CH plus 1 by CC divided by C minimum into 1 by CH plus 1 by CC. So this is my effectiveness formula for a parallel flow heat exchanger. Now, if CH is greater than CC, then CH will become C max and CC will become C minimum. Similarly, if CC is greater than CH, CC will become C max and CH will become C minimum. So, wherever CH or CC is there, whichever is max, you put it as C max, and whichever is minimum, you put it as minimum heat capacity. So, this is for the parallel flow heat exchanger. Now, let us move on to the counter flow. Similar LMTD का हाफ डेरिवेशन बाद में हम सॉल्व करेंगे, पर LMTD काउंटर फ्लो में चेंज होता है ना. काउंटर फ्लो में क्या होता है? The fluids move in opposite directions, right? The fluids, they move in the opposite direction. So that is our counter flow heat exchanger. So let's try to solve the derivation of counter flow heat exchanger, right? So this is basically the graph of a counter flow heat exchanger. So you know the fluids here move in the opposite direction. Fluids move in the opposite direction. तो hot fluid आप देख रहे हो and cold fluid आप देख रहे हो, they both are moving in different directions. Hot fluids and cold fluids are moving in different directions. So you can see here, okay, they are moving in opposite, that is different directions. तो इनका values change होगा, right? तो इनका अभी graph देखेंगे. So here you can see what we were having in parallel flow. We were having in parallel flow THI minus TCI, right? But in counter flow we have THI minus TC naught, and in this side we have TH naught minus TCI, right? In the parallel flow both were inlet and both were outlet. काउंटर फ्लो में क्या होता है, दोनों ऑपोजिट दिशा में जाता है, इसलिए दिस विल बी THI minus TC naught and this will be TH naught minus TCI. Right? Everyone understood this? Now the similar step will follow here. First one, differentiation. So dq equals minus UTA TH minus TC. My first equation. इधर क्या है, THI TH naught, ये भी negative है, TC naught TCI, ये भी negative है. So here you can see the inlet is moving from a higher region to lower region, and this is also happening in inverse direction. So basically inverse direction. If it was going in the direct direction, when you get it as positive, it is in the inverse direction, opposite direction, so it will become negative. तो negative negative दोनों cancel हो जाता है. So dq, इधर क्या है, in parallel flow we had a negative sign, in counter flow we do not have negative sign for both of them. So for cold fluid it will be mccpc dtc, and for hot fluid it will be mhcph dth, right? It will be mhcph dth. तो इधर dtc का वैल्यू बाहर निकाला मैंने, which will be dq divided by mccpc, dq divided by mccpc, dth का वैल्यू निकाला dq divided by mhcph. So now I have the next equation, which is dth minus dtc is equal to d of th minus tc, right? Either d and d is common, so I'll take d common, th minus tc. So what is dth? dq by mhcph. What is dtc? dq by mccpc. So d of th minus tc is equal to dq is common in both this. Okay, इन दोनों में dq कॉमन है, तो dq को बाहर निकाल दिया मैंने, तो क्या बचेगा अभी? What is mhcph? What is MHCpH? It is nothing but CH, C of H, heat capacity of a hot fluid. MCCPC क्या है? Heat capacity of a cold fluid. So this is CH, MHCpH, heat capacity of a hot fluid. This is heat capacity of a cold fluid. So this is DTC, DQ by MCCPC. So MHCpH is nothing but CH, MCCPC is nothing but CC. तो इधर negative negative ही रहेगा, and this one will have a positive sign, which in parallel flow was having a negative sign. Now the next part of the equation, d of th minus tc, d of th minus tc minus uda th minus tc. So how did this come? How did this come? dq is there. What is dq? dq is minus uda th minus tc, है ना? So that is what I have written here. Then again, ये जो tc है, मैं इसको denominator पर डालूंगा, मतलब next one. So this will come to the denominator. I will move to the next side, so it comes to the denominator. UDA into 1 by CEC minus 1 by CH, 1 by CC minus 1 by CH, right? So now TH minus TC, exit और inlet, इसका integration लेना है मुझे, exit और inlet का integration, and this one will be same, UDA will be there, DA will again become A. So exit and inlet, इधर क्या difference होगा अभी मैं बताता हूँ, ठीक है? So 1 minute guys, I'll just erase this. Okay, so you can see here. So this is basically the inlet, है ना? ये inlet of the heat exchanger है, ये outlet of the heat exchanger है. ये actually cross counter flow heat exchanger है, इसलिए इधर opposite दिशा में जाता है. But basically this is the inlet and this is the outlet or exit, right? तो exit का temperature difference क्या है इधर? TH0 minus TCI, है ना? TH0 minus TCI, this is the exit temperature difference. Inlet का temperature difference क्या है? THI minus TC0, right? THI minus TC0. You guys understood? So the same thing, this one and this one substituted here. Okay, ln of TH0 minus TCI, that is the exit का equation. Then divided by THI minus TC0, inlet का equation, is equal to UA 1 by CC minus 1 by CH. UA 1 by CC minus CH. So similarly, what we did in the previous derivation, ln we will move it to the left hand side. When the ln moves to the next side, it becomes e power. It becomes exponential power. So UA goes to the power. When ln comes to this side, it will become e power UA 1 by CC minus 1 by CH. 1 by CC minus 1 by CH. If you go to the previous derivation, this is counter flow. Counter flow का मतलब है opposite flow. So the heat transfer is itself taken in negative. Okay, this is opposite or counter flow. Heat transfer is itself taken in negative. So the negative equation comes here. Okay, UA, it is actually the heat transfer is happening in a counter flow, right? Hence we take the negative thing. We take the negative sign here, minus UA CC by CH. Now we'll move forward to our effectiveness derivation. Okay, so effectiveness, we know it is a maximum possible heat transfer divided by actual heat transfer happening. Okay, actual heat transfer, this is actual heat transfer divided by maximum possible heat transfer happening. So actual heat transfer, when you consider hot fluid, it will be CH into THI minus TH naught. And when cold fluid considered, it will be CC into TC naught minus TCI. The denominator term will always remain the same. That is the maximum possible heat transfer happening in a heat exchanger. It is C minimum divided by THI minus TCI. So do not consider this, sorry. This is actual by maximum possible heat. So this is our effectiveness. Now let me write this effectiveness. Okay, तो अभी मुझे TH नॉट और TC नॉट का वैल्यू चाहिए दोनों साइड से, राइट? TH नॉट और TC नॉट का वैल्यू चाहिए मुझे दोनों दिशा से. तो एप्सिलॉन का वैल्यू क्या होगा इधर? ओके, हियर बेसिकली सो CH into THI minus TH naught into C minimum by THI minus TC. So this one we will get here. Okay, since this is a counterflow heat exchanger, so CH into THI minus TH naught is equal to epsilon C min. This will be one term. Okay, if I just take THI minus TH naught outside, CH will become its denominator. So epsilon C min divided by CH into THI minus TCI. Now I have TH naught here. So this should be minus. So what will I get? THI minus epsilon C min, right? TH naught minus is there. So ये इस side जाएगा, negative negative. So I'll get THI minus. So THI minus, which will be my fourth equation. Then again the cold flow का equation इधर है. So I want TC naught outside here. So but here TC naught is in the positive sign only. So क्या मिलेगा मुझे इधर? TCI plus epsilon C minimum C naught. Similar to what we saw in the previous derivation. Just substitution. 4 और 5 मिल गया. अभी TH नॉट और TC नॉट को इस वैल्यू में सब्स्टिट्यूट करो. पर ये क्या है? इधर ही हमारा डिफरेंस है. पैरेलल फ्लो में TH नॉट TC नॉट सेम लाइन में था, मतलब न्यूमरेटर में था. पर इधर TH नॉट जो है वो न्यूमरेटर में है और TC नॉट जो है वो डिनोमिनेटर में है. So TH नॉट और TC नॉट वैल्यू सब्स्टिट्यूटेड. Okay, let me erase this once. Okay, yes, now TH naught TC naught we found out. Substituting it, this value will be TH naught and this value will be TC naught, right? So substituting it, we will get in the numerator THI minus TCI minus epsilon minimum, epsilon into C minimum by CC, THI minus TCI divided by THI minus epsilon into C minimum divided by CH, THI minus TCI minus TCI. So similar to the previous one, here THI minus TCI are common. THI minus TCI are common. So taking THI minus TCI out, what will we get? Here 1 minus epsilon will come because 1 minus is the THI minus TCI is common. So it will be replaced by 1 and here also it will be replaced by 1. So दोनों साइड में क्या होगा? इधर CC है, इधर CH है, तो वही डिफरेंस होगा. इसको भी कैंसिल मत कर दो, ठीक है? ये CC है और ये CH है. तो taking out THI minus TCI out, which is common, we will get 1 minus epsilon C minimum divided by CC divided by 1 minus epsilon C minimum divided by CH, which is e power minus UA 1 by CC minus 1 by CH. So ये counter flow का है, दोनों हम कैंसिल कर देंगे. What will be remaining here? 1 minus epsilon C minimum by CC divided by 1 minus epsilon C minimum by CH. That will be remaining here and the right hand side, which will remain the same. Now the next form of the equation. Okay, next form of the equation. तो इधर क्या है? 1 minus epsilon C minimum by CH है ना? This one is there CH. So when I multiply this, ये क्रॉस मल्टीप्लाई होगा तो क्या होगा? 1 into 1. So e power minus UA का दो टर्म होगा ना? E power minus UA into e power minus UA because 1 is there. 1 into e power minus UA. E power minus 1 minus e epsilon C minimum. So e power minus UA दो बार रिपीट होगा अभी राइट हैंड साइड में because 1 minus is there, दो बार रिपीट होगा. तो हमारा नेक्स्ट इक्वेशन क्या होगा? e power minus UA will get repeated 2 times, right? So 1 minus epsilon C minimum. Okay, 1 minus epsilon C minimum, this will remain on the left hand side, right? This will remain on the left hand side. Right hand side में e power minus UA 1 by CC minus CH minus epsilon min by ch into e power minus ua 1 by cc minus ch. As I told, this one was 1 minus epsilon c minimum by ch, है ना? तो 1 minus था ये, तो क्या होगा 1 into e power minus ua. So this will get multiplied first and next e power into this. So two terms of e power minus ua will come. So please do not get confused here, students. Okay, 1 minus epsilon c minimum is there. So epsilon c minimum into e power minus a, 1 into e power minus ua. So 2 times e power minus ua will come here. Right? Everyone understood now? Okay, this will come. Now what shall I do? I will take 1 minus e power minus ua 1 by cc minus ch. Okay, 1 minus will be on the one side. In the next side, I will take epsilon c minimum as common. Epsilon c minimum is common here only. What will we get? We will get 1 by cc, 1 by ch, 1 by cc minus 1 by ch into e power. So this e power ch, they are a single term. This e power ch is basically a single term. E power c minimum by ch into e power minus ua into 1 by cc by ch. This is a single term. Okay, this single term and this term, इन दोनों में से एप्सिलॉन सी मिनिमम कॉमन है, तो एप्सिलॉन सी मिनिमम कॉमन लिख दिया, 1 by cc बाहर लिख अंदर लिख दिया, 1 by ch into this one is present, है ना, into this one is present here, into this one is present. So that I will write it off. That I will write it off on the left hand side. तो right hand side में क्या बचेगा? 1 minus e power minus ua 1 by cc minus ch, right? 1 minus this one will be remained in the right hand side. What do I need? What do I need? I just need the effectiveness. I need only the effectiveness ka formula. So epsilon will be this whole term. This whole term which I am underlining over here, it will go to the denominator of this term. That is 1 minus e power minus ua into 1 by cc minus ch divided by c minimum 1 by cc minus 1 by ch into e power minus ua cc into 1 minus cc by ch. So this will be the effectiveness of counter flow heat exchanger ka derivation, or the last formula, the formula to find the effectiveness of a counter flow heat exchanger, right? Assuming again, if cc is greater than ch, then cc will be c minimum, ch will be c maximum, and if ch is greater than cc, c will be c maximum and ch will be c minimum, right? इसका उल्टा होगा अभी, है ना? So writing it down, तो जिधर भी ch है c minimum लिख दो, जिधर भी ch है, जिधर भी c minimum है, that is if cc is c minimum, then write wherever is cc as c minimum. If ch is maximum, then wherever ch is there, write it as maximum. But we know that ua divided by c minimum is ntu. This formula we did not have to use in parallel flow, क्योंकि parallel flow easy है, easy में आ गया. But मैंने starting slide में ही क्या दिखाया था कि number of transfer units is nothing but ua divided by c minimum, है ना? Number of transfer unit is nothing but ua by c minimum. This I showed you guys in the first slide only while before solving the parallel flow heat exchanger. So ua by c minimum किधर है देखो, this here one side is there, another side is there. So this is in minus ua by c minimum, minus ua by c minimum, तो क्या होगा minus ntu होगा ना. ua by c minimum is plus ntu, minus is there, minus ntu, substitute this as minus ntu. Now I can also do another thing. The c minimum by c maximum, I can write it as c. Okay, so I can write the value c as the ratio of c minimum by c maximum, है ना? c minimum और c maximum दोनों का वैल्यूज हमें मिलता है प्रॉब्लम से. तो the ratio of c minimum by c maximum is nothing but the capital C. I will write the c minimum by c maximum ratio as c. So let's term this c minimum by c maximum, okay, as c. The final equation will be 1 minus e power minus ntu into 1 minus c divided by 1 minus c power minus ntu into 1 minus c. So this will be my final equation where c equals c minimum by c maximum. Okay, so we'll see some special cases. Okay, when c max is equal to infinity for parallel flow, this will be the effectiveness ka equation. that is 1 minus e power minus NTU into 1 minus C minimum by C maximum. So C maximum is infinity, so anything by infinity will become 0. So into 0 into 0, so the final equation will be epsilon is equal to 1 minus e power minus NTU when C max is infinity. Similarly, when C max is infinity in counterflow, so jidhar bhi C max infinity dal do, you will get the same answer again. So when C max is equal to infinity, the effectiveness of a parallel flow and the effectiveness of a counter flow will be same, that is will be equal. Now when C minimum by C maximum is equal to 1, when C minimum divided by C maximum is equal to 1, तभी C minimum by C maximum किधर भी है, okay? So we'll go back to the previous one. C minimum divided by C maximum is there, okay? C minimum divided by C maximum here and C minimum divided by C maximum here is there. So substitute this C minimum by C maximum as 1, right? Substitute this C minimum by C maximum as 1. You'll get the answer as 1 minus e power minus NTU power 1 plus 1 divided by 1 plus 1. So this will basically become 1 by 2 into 1 minus e power minus n minus 2 NTU, because 1 plus 1 is 2, so it will become 2 NTU. This is for parallel flow. For counter flow, C minimum by C maximum की जगह 1 डाल दो, 1 minus e power minus 0 हो जाएगा, divided by 1 minus e power minus 0 हो जाएगा, which is basically 0 by 0. We cannot take 0 as an effectiveness, so we will write this one as NTU divided by 1 plus NTU, right? So either 1 minus C minimum by C maximum. Here 1 plus was there. So here 1 minus 1. So this will become 0. Anything to the power of 0 is 0. So 1 minus e power 0 is 0. So 1 minus 0, 0. So basically 1 by 1, which is nothing but 0, will be there. 0, you cannot take it as an effectiveness. So we will write an alternative formula for that, which is NTU divided by 1 plus NTU. This is only when C minimum by C maximum is equal to 1 for a counter flow heat exchanger. Only when C minimum by C maximum is equal to 1 for a counter flow heat exchanger, we use this formula, because the effectiveness becomes 0 by the older formula, right? So that was the end of the session, guys. Okay, so if you guys are planning to buy the Unacademy Plus subscription, please do use my code Shreyas to get a 10% off. And if you are buying for more than 3 months, then you can also use your credits, Unacademy Learning App credits, and get a total of 20% off. That is the credits 10% off and my referral code 10% off. If you are buying for more than 3 months ka subscription, you will be getting 20% off subscription. That is 10 from my referral code and 10 from your credits. If you are going to buy only 1 month subscription, you can use my referral code Shreyas to get 10% off. So these are the different benefits of Unacademy Plus subscription. You'll get lessons by top educators. There will be weekly quizzes and doubt clearing sessions, and all live and structured courses according to the GATE 2020 pattern are found in the Unacademy Plus platform for GATE. You will find out all types of courses from mechanical to CS, as well as all types of, so civil engineering is also there, chemical, all engineering branches which are affiliated to GATE can be found in the Unacademy Plus platform. Okay, so thank you guys. See you in the next special class. Okay, my next special class I'll be scheduling it again in the coming weeks. So I will give you an intimation. You can get an intimation in the Unacademy subscription channel, which is in the YouTube, which you have subscribed already. So you guys will be seeing. So my further around 3 to 4 special classes, it will be again in the same heat exchanges topic, and I'll also take some 3 to 4 same YouTube live classes on the topic of general aptitude, which is numerical ability as well as verbal ability. So it was nice interacting to all of you. Have a good night. Thank you.